Welcome to our lesson on properties of equality. This is Unit 2, Day 5, and this lesson will conclude Unit 2. As you go along through the lesson, you may have to hit pause so you can copy down some of the notes and definitions, or hit rewind if you need to see anything again. Here are the properties of equality. All of these properties you learned in Algebra 1. So take the time to copy down the definitions and hit pause. So here are the properties of equality that you'll need to copy down. I would like for you to notice that we start off with A equals B. And if you notice over here, what did we do to each side? We added C, and that's the addition property. For the subtraction property, we started off with A equals B, and you notice over here, it's minus C, that's the subtraction property. In this third one, we have C multiplied on both sides, that's going to be the multiplication property. C is being divided on both sides, that is going to be the division property. And this is an all-time favorite in Algebra 1, the distributive property. Once you multiply the outside number by every number on the inside, you get A times B plus A times C. This one is substitution. Think about it as in basketball, football. Take somebody out, replace the point guard with the point guard. So A equals B. Then A may be replaced for every B, and B could be replaced for every A. Notice this one, A equals A. A looks in the mirror and it sees its reflection. This is the reflexive property. The symmetric property, you go from A equals B to B equals A. It's just a turnaround. Here we go with the transitive property. This one reminds me of the law of syllogism that we just studied. Here we have A is equal to B and B is equal to C. And then we're happy to say that because B connects the two, then A is equal to C. So what we're doing in this unit, we're going to be writing something called a two-column proof. And what you're going to notice with the two-column proof is there's going to be a left side and there's going to be a right side. And so with that, you will notice that on the left side, we will have all of our statements or our steps. On the right side, we will have our reasons that will justify each step. So if we notice that something was being added to both sides in our statement, our reason would be the addition property of equality. Now, what can be used? Well, let's take a look. What can be used as a reason is any property of equality. We can use any definitions. We can use any postulates, and we can use any theorems. So let's talk about what can't be used. You can't say that it looks equal, because guess what? That's not a property or a definition. That's you trying to take a look at it and thinking that it looks equal. Can we use this? And the answer is no. So let's get started. We're given that 4x minus 1 is equal to 27, and then x, we need to prove that x is equal to 7. So notice in statement 1, we have 4x minus 1 is equal to 27. Why is that? Oh, it was given. Take a look here. This is something they gave us. Now, take a look as we move to step 2. Step 2 looks different than step 1. So we want to think about what happened as we move from step 1 to step 2. Well, I see a 1 is missing. This negative 1 is missing. So what happened is they added 1 to both sides. Therefore, this side went up from 27 to 28. And so the name of that property is, you got it, the addition property of equality. Now let's take a look and see what happened as we move from step 2 to step 3. And no longer have the 4 and no longer have the 28. We divided. Anytime something is getting smaller, 28, we went from 28 to 7. Two things can happen. We're subtracting or we're dividing. However, over here I see I went from 4x equals 28 to x is equal to 7. So that is the division property of equality. So here we have it. What did we do? We have statements over here, and we justified every step with, we justified every step with our reasons. All right, let's take a look at this one. We're starting off, we rewrote what was given and our reason for that. It was given. Let's take a look to go from step 1 to step 2. Something happened. We have a positive 2, it's gone. So what property is that? You got it, subtraction property. Now let's take a look and see what's going on as we move from step 2 to step 3. I noticed I had a negative 6 in the denominator and it's gone. And however, I can see that each side was multiplied by 6. Which property is that? That is the multiplication property. Sometimes students will call it the multiplicative inverse, and that's completely acceptable. Let's move on. Let's see if you can push pause and you try this one on your own. And once you've tried it, hit play and follow through the steps. Okay, let's take a look and see what's going on. We start off on line 1. And what's the reason for having this? It was given. How does line 1 look different from line 2? We've lost the parentheses. We've used the distributive property. How does line 2 look different from line 3? We had plus 27 and it's gone. We subtracted 27 on each side. That's the subtraction property. We had x with a coefficient of negative 18. We divided each side by negative 18 and we got x is equal to negative 2. What was that last step? It was the division property of equality. We actually proved that in this problem, x is equal to negative 2, and we justified each step. That's what a proof is. It's getting from a starting place to an ending place and justifying every step along the way. And then we come to these beautiful proofs. Well, we have statement column and a reasons column, and we have to write all of it. So what do you think we should write first? We're going to start with what's given. And what's the reason for me writing that statement? It was given. Now what I need to do is, my goal is to prove that x is equal to negative 5. So I'm going to have to get x by itself. So the first thing I'm going to do is subtract 1 on each side. So take a look at this. When I subtract 1 on each side, I get 3x is equal to negative 15. That was called the subtraction property. Let's see what we do next. I need to get x by itself. I'm going to divide both sides by 3. And I get x is equal to negative 5. What property was that? That was the division property of equality. Now, we have one more row here. Does that mean we have one more step? Well, we don't go by rows. We go by, did we prove what we needed to prove? X is equal to negative 5. X is equal to negative 5. And so we get a check plus. I would recommend that you take a few minutes and try some of the problems in your packet and then come back to the video as we move on. In this section here, if you were in class, we had the answers posted around the room. However, you're watching the video. So what we're going to do is we're going to take a look at all the properties of equality and we're going to fill this in. Take some time to go ahead and copy down these properties of congruence. And notice here we have the reflexive property, symmetric, transitive, definition of congruence as we move from the congruent symbol to the equal symbol, or the equal symbol to the congruent symbol. We also have a definition of midpoint, and we have a postulate called the segment addition postulate, which we'll talk about later. Go ahead and take the time to copy this down. On this slide here, we're going to take the time to go over maybe the first four, and we're going to justify what's going on in each step. So take a look at number one. It says if PQ is equal to PQ, then segment PQ is congruent to segment PQ. I'd like for you to go ahead and write down that this is one of the, this is the definition of congruence. So there it is, definition of congruence. I'm pointing to it at the bottom. So if you go ahead and write that in. Let's take a look at the next one as we read through. It says if K is between J and L, then JK plus KL equals JL. Well, I don't know about you, but I think I need a little picture so I can visualize this. It says K is between J and L. It didn't say in the middle, just said in between. And so then it's coming back and it's saying that JK, so let me see JK, and KL is equal to JL. So what I'm seeing is this part plus this part equals the whole thing. So this is part plus part equals what? Ooh, can I write it any bigger? Part plus part equals whole. That is, folks, our segment addition postulate. You get it? Segment addition. We're adding parts of the segment together. Let's quickly take a look at number 3. EF, segment EF is congruent to segment EF. I would say EF looks in the mirror and it sees itself. So that's going to be, look at my little check, my arrow here. That's going to be the reflexive property. The last one we're going to do together is number 4. Take a look at number 4. If RS is equal to TU, so they're giving me that. RS is equal to TU. So what happened here? Oh, I see. They added XY to each side. You know what postulate that is? You got it. It is the addition postulates. Addition's property of equality. There you go. Try the rest of them on your own. And then when you can, show them to your teacher so that you can see if you did those correctly. All right, let's practice this last one. And what we're going to do is we're going to use this little word bank over here to just help us work through this proof. What you want to do when you're starting a proof is you want to read the directions, complete the proof below by giving the missing statements and reasons. Well, as I can see, they've given me all the statements, so now what I need to do is give them the reasons. What I notice here is it says E is the midpoint of DF. We talked about if something is in the middle, then the parts are congruent. So they want us to prove that if we have 2 DEs, that it is equal to the whole thing. Well, I agree with that because when I think about it, if this is 5, then this is 5. So the whole thing is 10. So if I had 2 5s, it would definitely be equal to the whole thing, which is 10. So let's go ahead and get started after we've made sense of the problem. So let's see if we can copy down the reasons. When I look at number 1, it says E is the midpoint of DF. Oh, awesome. That's given. Got it. When I look at number 2, it says DE is equal to EF. Come over here. DE is equal to EF. Oh, I know what that is. Why would they be equal? That is the definition of midpoint. So I'm going to write that down. Definition. I'm going to abbreviate of midpoint. All right. So as I look at number 3, I notice that I start off with DE on one side and I have EF on the other side. And they have added DE on each side, and that is the addition property. As I move from step 3 down to step 4, the right-hand side did not change. DE plus EF is still DE plus EF. However, over here I see DE plus DE is 2 DEs. That is called combining like terms, or from our word bank, let's pick simplify. So when I take a look at this one right here, DE plus EF equals DF. What part of the segment is DE? Part. What part of the segment is EF? Another part. And what is DF? The whole thing. So DE part, EF part, DF whole. So part plus part equals whole. Guess what that is? That's going to be your segment addition postulate. Okay. Let's see what we have now. Oh, I like it. Take a look at this. I went from DE equal DE plus EF. And then I have the same thing right here, DE plus EF, which would say DE, let me color it in black, is equal to, two DEs would be equal to DF. So as we did with the lost syllogism, the part in the middle is the same. So the first connects to the last. Looks a little sloppy. But we're able to say that 2 DEs, which was the first part, is equal to DF, which is the last part. And that is your transitive property. Alrighty, this concludes the video and the video lesson. Please practice some of the problems in the book before you proceed to homework.